Hello viewers, you are welcome to my YouTube channel. In today's video, we're going to solve this elegant integral. So we have integral from 0 to infinity of 1 over x cubed plus 1 over x cubed, then raised to the power of 2dx. Okay, so if you are new to this channel, please don't forget to subscribe, like, comment, and share. All right, so let's start solving. So the first thing is to simplify the denominator completely. So if we do that, we have integral from 0 to infinity of 1 then over, the LCM here will be x cubed. Okay, so we have x cubed. So if we divide x cubed by 1, that's going to give us x cubed. So x cubed times x cubed going to give us x raised to the power of 6. Then plus x cubed by x cubed are going to give us 1. So if we multiply by 1, we're going to have 1. Then raised to the power of 2, then we have the x. And according to the law of indices, we have a over b raised to the power of n. So this would be a raised to the power of n, then over b raised to the power of n. So we can do the same thing here also. So if we do that, we have integral from 0 to infinity, then of 1, then over, we have x raised to the power of 6 plus 1 raised to the power of 2. Then we have x raised to the power of 3, then raised to the power of 2 dx. Okay, so this will be equal to integral from 0 to infinity. Then, x raised to the power of 3 raised to the power of 2 will give us x raised to the power of 6. So take note of that. Then if you have 1 over a over b, so that's going to give us b over a. Take note of that also. So we're going to have x raised to the power of 6, then over x raised to the power of 6 plus 1, so raised to the power of 2 dx. All right, so next thing we're going to do here is to make a substitution. So we make a substitution, so we can say let x raised to the power of 6 be equal to t. Then if we do that, we have x raised to the power of x equal to t raised to the power of 1 over 6. All right, the next thing we're going to do now is to differentiate. So we have dx is equal to 1 over 6, t raised to the power of 1 over 6 minus 1 dt. All right, so that is what we have. So we can write, and then the limit is not going to change because we set x to be infinity, t will also be infinity, and if we set x to be 0, t will also be 0. So we have integral from 0 to infinity of x raised to, sorry, instead of writing x raised to the power of 6, we write t. So we have t then over t plus 1 then the raised to the power of 2. So instead of you writing the x, so we can just write this. So we have 1 over 6 t raised to the power of 1 over 6 minus 1, all right, dt. So we can factor out 1 over 6. So we have 1 over 6 integral from 0 to infinity. Then t multiplied by t raised to the power of 1 over 6 minus 1. So if we apply the law of indices, that will give us t raised to the power of 1 over 6, then over t plus 1, then raised to the power of 2 dt. Okay, so for us to solve this problem completely, let me quickly remind us the beta function formula. We have beta of a b is equal to integral from 0 to infinity, then of t raised to the power of a, then over 1 plus t, then the raised to the power of a plus b dt. Okay, so that is this is t raised to the power of a minus 1. Sorry, I forgot to put a minus 1 there. I'm very sorry for that. All right, so that's the definition of the beta function. Okay, so how can we write this integral right here in this form? Yeah, so that's another thing that we must be able to do. It's very easy though. It's very easy. So if you look at this now, this is a minus 1, and here we have 1 over 6. Okay, so how can we find the value of a from that? So I can just equate. I can say a minus 1 is equal to 1 over 6. Then if you add 1 to the both sides, so I have a is equal to 1 over 6 plus 1. So that is the value of a. So the next thing is to know the value of b. So since we know that a plus b will give us 2 right here, and we already know the value of a, which is 1 over 6 plus 1, then I can say 1 over 6 plus 1, which is a, then plus b give me 2. So if I subtract this from both sides, I'm going to have b is equal to 2 minus 1 over 6, then minus 1. So we know 2 minus 1 is going to give us 1. So we have b is equal to 1 minus 1 over 6. That's beautiful. That's beautiful. All right. So 1 over 6 integral from 0 to infinity of t. So instead of writing 1 over 6, so I could write 1 over 6 plus 1, then minus 1. 1 over 6 plus 1 minus 1. then over t plus 1. Then instead of me writing 2, so I could write 1 over 6 plus 1, then plus 1 over 6, sorry, 1 minus 1 over 6, all right? 1 minus 1 over 6. Okay, dt. So this will give us 1 over 6. So this is in form of the beta function now. And since we have the value of a, which is 1 over 6 plus 1, and we have the value of b, which is 1 minus 1 over 6. So we have beta of 1 over 6 plus 1. Say 1 plus 1 over 6, comma 1 minus 1 over 6. All right. So that is what we have then. Let's simplify this completely. So let's go to the new page. So we have 1 over 6, beta of 1 plus 1 over 6, then a comma, we have 1 minus 1 over 6. So let me quickly remind us the definition of the beta function in terms of gamma function. You know, beta of a comma b will give us gamma of a multiplied by gamma of b, then over gamma of a plus b. Take note of that. It's very important. All right, in this case, since we know a is 1, b is 1 over 6, a is 1 plus 1 over 6 and b is 1 minus 1 over 6. So we'll have gamma of 1 plus 1 over 6, then multiply by gamma of 1 minus 1 over 6, then everything over gamma of 1 plus 1 over 6, then plus 1 minus 1 over 6, okay? So 1 over 6 minus 1 over 6 will give us 0, and we know 1 plus 1 will give us 2. Okay, so we have gamma of 1, then plus 1 over 6, then multiply by gamma of 1 minus 1 over 6, then everything here over gamma of 2. So we know gamma of 2 will be 2 minus 1 factorial. Since the definition of gamma, if you have gamma of n, that's going to give us n minus 1 factorial. So gamma of 2, that will be 2 minus 1 factorial, and 2 minus 1 factorial is 1 factorial, so which is equal to 1. So what we have now is a gamma of 1 plus 1 over 6, then multiply by gamma of 1 minus 1 over 6. Okay, so remember that if you have gamma of 1 plus a, then multiply by gamma of 1 minus a, so this is going to give us pi of a over sine pi of a, all right? So in this case, the value of a is just 1 over 6, so this is going to give us pi of 1 over 6, then over sine of pi, then multiply by 1 over 6, okay? So this is going to give us pi over 6, then I multiply by, 1 over sine of pi over 6. And then sine pi over 6, I think that should give us half. Yeah, that should give us half. So we're going to have pi over 6, then into 1 over half. Okay, so if we divide 1 by half, that should give us 2. So we have pi over 6, then multiply by 2. So 22, that is 1. 26, we're going to give us 3. So we have pi over 3. And then we remember that this is 1 over 6 right here. Okay, so we're going to have 1 over 6, then multiply by pi over 3, and that's going to give us pi over 18. And so that is the answer to that elegant and beautiful integral. So therefore, and we write it down, this integral right here, integral from 0 to infinity of 1 over x cubed plus 1 over x cubed raised to the power of 2, the x will surely give us pi over 18 as our final answer. Okay, so if you like this kind of video, please don't forget to subscribe, like, comment, share, and then thanks for watching, and make sure you come back next time. Thank